So for this video, we're going to look at two different trig concepts. First, based off information that you are given, can we figure out what quadrant the terminal point lies in? And then also, given a trig expression, can you tell me the sign of that terminal point? So we're first going to look at, given some information, let's find the quadrant that the terminal point lies in. So after you work with trig enough, a lot of times you do start to memorize the signs for all the different functions. Until then, there is a little table here that kind of summarizes everything. You can also use your unit circle to also get the signs of some of these values here. So I've just taken this little table that does tend to pop up in a lot of trig books here. They're going to help us figure this out. So the first thing that we're given here is what quadrant is sine theta greater than 0, but cosine theta is less than 0. So taking a look at the chart over here, quadrant 1, everything is positive. So if you have something that's saying that it's negative over here, like we have cosine theta is less than 0, we know we're not talking about quadrant 1 because anything less than 0 is not positive. Also, we're looking for when is sine positive, when is cosine negative. So if I move over here down to quadrant 4, it says cosine is positive over here. We want it to be negative, so that throws out 4. Quadrant 3 says tangent and cotangent are positive, but everything else is negative. Well, since we want sine to be positive, it says sine is negative in this one. That means that more than likely this point here lies in quadrant 2, but we could just be sure. Sine theta is greater than 0. It does stipulate right over here that sine is greater than 0. It also says cosecant is greater than 0. That one doesn't apply to us. And it says everything else is less than 0. So it looks like this is the one for us. This point would lie in quadrant 2 because sine is greater than 0. Cosine is less than 0 for this one right over here. So then tangent. If we're looking for where is tangent positive, where is sine negative, right? So it obviously can't be 1 because everything needs to be positive there. So let's see, quadrant 2, everything is negative except for sine and cosine, so that's not going to help us when we need tangent to be positive. Let's see, quadrant 3, tangent is greater than 0. Cotangent is also greater than 0, and it says everything else is less than 0. That means this sign right over here would fit within that. Tangent is greater than 0, but sine is less than 0. So it looks like we are looking at quadrant 3 there. So this is really just a comparison game. All right, take our given stipulations, match it up with the signs. For this third one over here, we're looking for when is cosecant greater than 0. So let's see, since these bottom stipulations, others less than 0, others less than 0, others less than 0, it's easier to just find when is cosecant greater than 0. That looks like quadrant 2, and let's see if that fits. Because quadrant 2 does say cosecant is greater than 0. Secant is less than 0. So secant would fall in this others over here. So it looks like this would be quadrant 2. Now we're looking for when is cosine less than 0, when is cotangent less than 0. So we don't want cosine or cotangent to be positive. So if we don't want cosine or cotangent to be positive, we want each one of those to be negative. Well, let's see. Cosine is positive here, cotangent is positive there. Everything is positive in 1. So it looks like we are looking at quadrant 2, where everything except for sine and cosecant is negative. So it looks like quadrant 2 does fit our stipulations here. For this set of examples, we are going to determine from the given information, find the sign of the expression in the given quadrant. So this first example, if we're looking at tangent theta times cosine theta, specifically in quadrant 2. All right, so we're talking about quadrant 2, so we want to zero in on these stipulations here. And we're going to multiply tangent theta times cosine theta, and we want to know what sign would we get when we do that. So let's first take a look at tangent theta. If we take a look at tangent theta over here in quadrant 2, quadrant 2 says that sine and cosecant are positive, otherwise everything else is negative. So since tangent isn't labeled up here, that means tangent is negative, right? It's going to fit into the others stipulation that's here. Same thing for cosine. Sine and cosecant are positive, everything else is negative, which means cosine is negative. So tangent is going to be negative, times cosine is that going to be negative, and a negative times a negative is positive. So whenever we calculate this expression, we are going to end up with a positive value there. If we move down to the example right below this here, we have sine squared theta times cosine theta, and we're talking about our quadrant 4. So we want to zero in over here to quadrant 4. In quadrant 4, cosine and secant are positive. So let's see, we do have a cosine right over here. So it means that this cosine would be positive. It says cosine and secant are positive. Everything else would be negative. So that means the sine over here is going to be negative. Now do keep in mind that is sine squared. So that means we're going to have two of those negatives, right? A negative times a negative. Or just throw in a negative value for it. And we know that that's going to be squared. A negative squared, negative times negative is positive, times the positive value of cosine theta would leave us with a positive situation, giving us a positive value there in the end for that one. Taking a look at our third example, here we have tangent theta times sine theta over cotangent theta, and we're talking about specifically in quadrant 3 over here. Quadrant 3 says that tangent and cotangent are positive, so that means this tangent here, this cotangent here are going to be positive. I'm going to go ahead and put those in. Everything else is going to be negative. So that means this sine theta over here will be negative. So if we're taking a look at this stipulation, in the numerator, positive times negative is negative, over the positive that we had in the denominator, but different signs here, a negative divided by a positive is going to end up negative. All right, so we're going to have a negative sign for this third expression.